if you did, then you knew what is the problem. But if you didn't, yeah, please read the problem. Okay, now we have a 4x10 screen. 4x10. 4x10. On average, how many blank pixels? Here now? 4.1. 4.1 blank pixel, right? Can you see part A? We need the mean. Yeah, we have to get the mean. Where? On the square foot. 1 and 1. So in this case, we need another average, another mean on there. But it was 40 square feet, right? We had 4.1, but now it is the unit square foot. So did you 4.1 divided by 40? Did you do that? Take the answer in part A? Yeah. 4.1 over the size, 4 by 10, 40.
0.1025.
It will be 0.1025. 0.102533. Good, right? So we can take another average on the smaller size, right? Next, standard deviation. You know, we have it is a lambda. It is a new lambda. And it is the mean. Who was the standard deviation in Poisson? Square root of the lambda, right? So simply just take, did you take the square? Okay, good, thank you. So let me go to the next part later. So let me take the square root of 0.1025. I have a 32, how many did 3? Okay. 0.320. Okay, now part C. Oh, the size is getting bigger. It is bigger size, 2 by 3. So now we have a 2 by 3.
6 square feet.
2 by 3. The bigger size. We need another lambda. On the unit square foot, there was 0.103. Now the size is 2 by 3. 6 square feet. 6 times wider times 6. It will be the new lambda. So let me say it is lambda. So I have to say it is a lambda on 2 by 3. And it was the lambda 4 by 10. And it is another lambda unit square foot. Okay? So case by case, we have to update the lambda. So in part C, what is, it's not only the lambda. Okay, now we have lambda, is this one. Okay, and the question is, what is the probability? At least 1. We need a probability from here. We need a probability at least 1. What is the technique to get the probability at least 1?
complement.
Apply the complement probability. 1 minus probability x equal 0. E minus lambda. How much is that? 0.618 lambda x factorial. We can ignore it because it will be 1. We can ignore it too because it will be 1 as well. Can you take e to the negative 0.618, please? 0.539. 1 minus. Subtract from 1. Let me try. 461. Do you have an idea? Right? We have to take the new lambda every single time, depends on the size, and then apply the complement probability to take the probability at least 1. Should I do part D? No? It's fine? Why not? Let me finish. Yeah, I will. It's too small. It's too small. Yeah, here. What do we need? Oh, we need a probability. Okay. Oh, on 2 by 3. 2 by 3. Right? We are going to use the lambda. It was 0.618. Okay. We need a probability for what?
1 and 2.
Replace. We need a probability. Replace. When? When can we replace?
2 or more blank pixels.
The warranty policy states that
Screen solve that shows
more than 2
2.
blank pixels. More than 2. More than 2. Okay. The probability to replace it is the same as more than 2. Just a second. More than 2. Is it 2, 3, 4, 5, 6, 7, 8 or 3, 4, 5, 6, 7, 8? From 3, 4, 5. Yeah, more than 2 means 3, 4, 5 up to, unfortunately, infinite. Same idea. Apply the complement probability. 1 minus the others. How many the others? X equal 0, x equal 1, and x equal 2. What's this? X equals 0. Yeah, just the
We
copy.
just did it.
0.539. Take another one. Take another one. All subtraction, right? And you can take the probability to replace. Do you have an idea? Right? So not only at least 1, yeah? Anyhow, no, actually it was probability 1, 2, 3, and infinite. Right? So yeah, we can take the probabilities. Can you do that? Right? What is the answer? Anybody who got the answer? Didn't? You can try. So it has 4 questions. Everything regarding the Poisson probability model. Do you have any other questions? Okay, you can try. Did you print out the Z table? Thank you. Oops. Did we do this example? Okay, yeah. Can you remember? How can we get the probability from the Z table? The Z table gave us always left hand side, right? So do I need right hand side probability? Again, yeah, apply the complement probability. 100% minus left hand side will be the right hand side. Okay, and between, yeah, the same thing, right? Let me review here. I told you it is normal distribution. Who was the mean?
0.
0, thank you. Who was the standard deviation?
I. That I don't remember.
0, 1. 1 standard deviation was for the standard normal distribution. But now, the second one, the standard deviation, is just a sigma of value. Let me say it is 1. Now I can say it is a +1, +2, +3, -1, -2, and -3. Now I can say it is a standard normal distribution. Mean 0, standard deviation 1. Right? So it is a very special case. The mean 0 and standard deviation 1. Okay, now let me take the probability less than -1. Okay? So why don't you take your Z table? You didn't? I can show you. If you have your Z table, please look at your Z table. If you didn't have your Z table, then here it is. How much is the probability less than -1? -1.0. Second decimal place is 0.1587. Where? To the left. 0.1587. I want to take another probability less than +1. +1. How much will be the probability to the left? 0.8413. +1.0 and 0. 0.8413. Now, I need the probability in the middle. How can I take the probability in the middle?
Minus.
Yeah, please do it.
.84.
So just again, point. What?
84.
No.
No?
68. What? 26. It is about 68%. Exactly 0.6826. Good, right? Question. Let me try another one.
Yeah. That's what we're doing. Okay.
Less than -2. -2. -2. Less than, to the left, -2. How much is the probability? less than negative 2.
0.0228.
0.0228. 0.0228.
You can do positive 2.
And positive 2.
0.9772.
Positive 2. 2.00. 0.9772. 0.9772. 0.9772. Please take the difference.
0.95.
0.95.
44.
44.
I got it right.
Yeah, good. 0.95, 44. About 95%. You can try the next one. I don't want to do it anymore.
Okay.
Yeah. You will get about 99.7%. You can try. Any question? No questions? Let me ask you.
Mm.
How much will be the probability on the right hand side? What you are going to do? 1 minus 0.9772. Yes, try. 1 minus 0.9772. What you got?
0.0228.
0.0228. Here, right? 0.0228. Uh-oh.
What?
Why they are saying? Say again? The normal distribution is symmetrical. You don't have to 1 minus. You don't have to 1 minus 0.9772. It is same as that one, 0.0228. Why? Because
Symmetrical.
normal distribution is symmetrical. Okay? Why don't you try this one? Try this one. 1 minus twice 0.0228. Please do it. 1 minus twice 0.0228, please. What you got? 0.9 what? 0.954 and 4. Where was the probability 0.95, 4 and 4?
Right in the middle.
In the middle, right? What did I do?
Took both ends.
100% from negative infinity up to the positive infinity, right? Cut 1.0228. Cut the other 0.0228. Remaining in the middle, 0.95, 44. Anyhow, yeah, we can take the probability just in the middle between plus and minus 2. We are going to take about 95%. Exactly 0.95, 4 and 4. It is the 68, 95, 99.7% rule. You know, we can apply the rule only on the constant. Negative 1, positive 1. Negative 2, positive 2. Negative 3 and positive 3. And I expanded negative 4, positive 4, there is almost 100%. You remember that, right? Yeah. But you know, we have a z table. Yeah, actually, we don't need that one. But roughly, on the constant, yeah, we can take the probabilities. We can take the probability. Okay, let me ask you. By the rule. Can you tell me the probability there? By the rule, in the middle, there is 68%, right? How much will be the probability together, left end and together right end? In the middle, 68%. They are 32%. Can you get the 32%? 100% minus 68% will be they are 32%. How much will be the one of them? 16%. How much was it exactly? At negative 1. Point 15.
87.
0.1587, thank you. By the rule, it's about 16%. It's a 16%. How about here?
16%.
The other 16%. Why?
They're symmetrical.
Yes.
I got that one.
Less than negative 2. 95% in the middle. They are 5%, 2.5%, 2.5%. How much was it exactly from the Z table? 0.022 something. 2.5%. About 2.5%. Never mind. It's talking about statistics, right? 2.5% and 2.5%. Right? Yeah, it is very useful. But the problem is only on the constant. Negative 1, negative 2, positive 1, positive 2, positive 3. Right? But we have a Z table. Yeah, either way, we can take the probability. Good?
Yeah.
So, based on a standard normal distribution, either way, we can take the probability. Any question? Good. You took ACT, right?
Yeah.
It is the SAT.
Oh.
It is the SAT. How much is the mean? 500. Standard deviation? 100. Each SAT has distribution roughly unimodal, right? Symmetrical. It didn't say it is a normal distribution, but roughly the normal distribution. But the problem is mean is not 0, 500. Standard deviation is not 1 either, 100. What does it mean? It does not have standard normal distribution. So now we have a normal distribution, non-zero mean, low 1 standard deviation. So actually it is a 500, it is a 100. We discussed, we learned, when we have a Z, when we had standard normal distribution, only when mean 0, standard deviation 1. Then we can use the Z table, we took the probability. From where? From the Z table. We knew it. But unfortunately, now we do not have the standard normal distribution, right? Let me see. Here is a normal distribution, roughly. Normal distribution. Mean was 500, and the standard deviation was 100, and I got 600. It is not clear, but let me ask you take the probability on the right end. Yeah, I need the probability. I need the probability from here, not from here. Okay? If there is a bridge, we can cross to Z we can go to standard normal distribution. Oh yeah, we can take the probability from the z-table. Why not? Right? So we need a bridge. Yes, we have the bridge. The z-score will be x minus mu over sigma. What is the mu? The mean.
500.
500.
100.
Standard deviation,
100.
the sigma, it is a standard deviation, 100. Let's do it. We need the z-score at 600. How? X minus the mean divided by the standard deviation. It will be the z-score.
1%.
How much will be the z-score?
1.
Positive 1. How much was the probability? Less than 1? We have to go to the z-table. 1 less than 1. How much was the probability? 0.8413. 0.8413. On the left hand side.
So now I have to subtract it.
Thank you. Can you do that for me? 1 minus the probability, 0.8413 will be
1587.
1587.
87.
Thank you.
Little probability there.
Yeah. When I got 600 in SAT, I am top 16%.
Good job.
Yeah, thank you. How about this? Between 450 and 600. Okay, let me make another normal distribution here. Mean was 500. Now we need a probability between 450 and 600 in the middle. Yeah, don't be afraid. We can take the two z-scores at 450 at 600. How? 450 minus the mean divided by the standard deviation. The other one at 600, 600 minus the mean
We already know that one.
divided by 100 again. So how much will be the z-score at 450?
Negative 50.
Negative, it must be negative. 0.5. Second decimal place. 0.
Oh, yes.
You know, always we need the two decimal places to get the probability from the z-table. Always two decimal places. What will be the z-score at 600?
Use the 0.8413.
Yeah.
Say again?
0.8413.
I mean the z-score.
Uh-oh.
Oh, we took 1. Oh, okay, I'm sorry. 1.00. And you said up to 1 was 0.8413.
Yeah.
And can you tell me another probability up to negative 0.50?
0.3085.
Negative 0.50?
0.30.
3085? 0.3085? What should I do? Take the probability in the middle?
Subtract them.
Subtraction, yeah. 0.8413 minus 0.3085 will be
0.5328.
point what?
5328. Is that not right?
I'm sorry. How do you think? Easy,
Yeah.
right? Even though we had non-standard normal distribution. Any mean, any standard deviation. We can take the z-score. We can convert to the standard normal distribution. Now, we can take the probability from the standard normal distribution, from the z-table. Easy. It is easy, right? Good. I want to do another example here. How much is the mean?
32,000.
32,000. Standard deviation? 2,500. In part A, last longer than 40,000 miles. 40,000 miles. Right N. We need a z-score at 40,000 miles. X minus the mean divided by the standard deviation to take the z-score. How much will be the z-score? Should be positive. What? Say again? 3.2. Positive 3.20.
0, yes.
Can you tell me the probability less than positive 3.20? If you don't have your z-table today, please go into Google.
0.9993.
and please Google z-table.
It's
Then
still
you-
in the
you can-
files.
Yeah, absolutely.
That's what I'm using.
Yeah. Either way, you can visit the MyMathLab using your smartphone, and I posted the PDF file. Download the PDF file and open it. Yeah. So please looking for the probability. Yeah, on your phone. How much is the probability less than positive 3.20? 0.9993 on the left hand side, but we need the right hand side. What should I do?
Subtract it.
Thank you. 1 minus 0.9993 will be 0.0007. What is the probability 0.0007? On average, tires last 32,000 miles with the standard deviation 2,500 miles. If you expect last longer than 40,000 miles, don't even think about that. Never ever. It's a chance of 0.0007. No. Right? Why don't you do this one? Less than 30,000. Yeah. Here is the distribution. Mean was 32,000. Now, less than 30,000. I can expect less than 50%, right? Why don't you give me the z-score at 30,000? I can expect negative z-score because it is to the left. Negative z-score.
Oh,
And what is a negative z-score?
0.8.
Say again?
0.8.
0.8?
Yeah.
0.8? I don't know.
Oh,
Negative 0.8
yeah, negative 0.8.
Negative 0.8, thank you.
and 0.
80. Can you tell me the probability on the left hand side at negative 0.80? Point? Say again?
0.2119.
Yep. Yeah.
0.2119. Should I subtract from 1? No, we needed left hand side, and the z table gave us the left hand side probability. So it is the probability 0.2119. Okay, one more. One more. 32,000. Now between 30 and 35. Yeah, we are going to take two z-scores
We just did that one.
at 30, 35,000. Can you give me the z-score at 30,000 miles? Yeah, will be negative. What?
8.
0.8.
Up. Yeah, thank you. And positive at 35,000. Say again.
1.2.
1.20. Can you tell me the probability at negative point? We got it. How much was it?
0.8849.
No, I think it was 0.2119. Isn't it? And another one,
Oh,
less than positive 1.20.
0.8849.
Say again.
0.8849.
There is a probability 0.8849 at positive 1.20.
Yeah, so we have to subtract them.
We need the probability in the middle. 8849 minus 0.2119. How much would be the subtraction?
0.673.
6730.
Yeah.
That is the chance lost, the tires lost between 30,000 miles and 35,000 miles. Can you do that? Right? In this way, we can take the z-scores. Yeah? Now it is easy. Left hand side, right hand side, left hand side, right hand side, between, wherever we can take the probabilities. Any question? Please look at this. Minus the mean divided by standard deviation, right? I'm X. I'm X here. Short, fat, right? Yeah? And I'm stand on 100. It is my mean, 100, right? Yeah. What is the minus the mean, minus the 100? What happened? Minus the upper one, minus the mean. I'm moving and stop where?
No.
0. Right? What do we need? Standard normal distribution, right? I was not standard. I was here at 100. I was fat, right? Yeah? But minus the mean. Move, relocation, and set up at 0. Now the mean will be 0, minus the mean. But I'm still fat, divided by the standard deviation. You know, the standard deviation was the measure of the spread. Divided by the standard deviation is diet. Now I am the standard shape. Standard normal distribution, Right? It is easy. Relocation diet to make what? Standard normal distribution. So simply we can say this equation is a standardization. Make the standard normal distribution. Very simple. Right? Yeah. So please understand why we have to take like that to get the z, the standard normal distribution. It's very simple. It is very simple. Can you do that? Right? Okay, you can do that later. Please look at the next problem. Up to now, we took a probability. You know, not even in chapter 7, chapter 6, binomial model, Poisson model, we took probabilities. Yeah, look at this. Probabilities. Will be probabilities, right? Always in chapter 6, chapter 7, binomial model, Poisson model, standard normal distribution model, or even any kind of normal model asked us to find a probability, right? In part D, what do we need? Do we need a probability? No. What do we need? What is the question?
We need to find the x.
Mileage.
What is the mileage? You are asked to get not probability, but mileage. Where is the mileage on this map? Where is the mileage?
X.
The mileage is here, right? X. Yes, it is X. Mileage is here. We have to take the mileage. From where? From a probability. Can you see a probability in part D?
1/25.
1 out of 25. It is a probability. How much is this? 1 out of 25.
0.04.
0.04. Now, we have to go back home to take a mileage. Before, let's look at the before parts. A, B, and C. Mileage was given. And we took probabilities. We went to this way. Right? Yeah? But now, we have to go back to get the mileage from a probability, 0.04. Right? When we go this way, when we went this way, we just stop by the Z. Right? How do you think? Should I stop by the Z when I go back home?
Yeah.
Yes.
0.04.
In the middle, we need a Z-score. Where can you get the Z-score? Why not? The Z table.
Just find 0.04.
From a probability 0.04, at first, we have to take the Z-score. Let's take the Z-score. Oh, just a second. Just a second. We had a normal distribution. How much was the mean? Who was the mean? 32,000 miles. how much was the standard deviation? 2500. We have to put the probability somewhere, 0.04. Left end or right end? How do you think? Please read part D carefully and please choose either one, left end, right end.
Left.
Left? Why?
Because I'm looking at the Z chart and 0.04 is in the negatives. That's what I'm looking at.
Say again?
I just looked at this, found 0.04 and it's negative 1.7.
When I put the probability 0.04, then I'm looking for 0.96. That is not the reason.
So you want to go right.
How do you think? Where should I put the probability 0.04? Left end or right end?
Right.
Right.
Say again?
It's positive or something, right?
Is the right one?
Yeah.
Here? No, there. We have to put the, you're right, but the reason is wrong. And we need the mileage here. Please read the problem carefully, part D. It is a warranty problem. It is a warranty problem. Right? Average was 32,000 miles. Right? When I give you the warranty up to, for example, it's up to 40,000 miles. Warranty up to 40,000 miles. How much was the probability here? At the beginning? 0.0007? Right? When I give you, okay, you have a vehicle, I can give you 100,000 miles warranty. It's good for you, right? It's some car dealer gave us 10 years warranty, 100,000 miles warranty, right? But if I give you, okay, more, it's not only 100, 1 million mileage warranties. Are you going to buy the car? Right? Why not? It's a warranty, it's almost forever, right? What happened to me? I will bankrupt, right? On the right hand side? Oh, please don't do that. Okay? The warranty must be on the left hand side. We have to put the probability on the left hand side. Okay? So the probability 0.04 on the left hand side. We have to take the z-score. What to expect? The sign of the z-score. There. Negative or positive?
Negative.
Negative. Yes, negative here. Where is the probabilities? Where were the probabilities? Is
In
this a
there.
probability?
No.
Can be probabilities negative? No. Who are these?
Your.
That is a z-score. What we are looking for. And where were the probabilities?
Yeah.
Right? Inside, there are the probabilities. We are looking for 0.04, 0.04, 0.04, 0.04. Between these two. It is a 0.0401, a little bit bigger than 0.04. It is a 0.0392, a little bit less than 0.04. Between these two here,
Yeah.
there is the exact probability 0.04, right? What do we need? We need a z-score at negative 1.75 and negative 1.76. Can you take the average? Please take the average. take the sum, negative 1.75 and negative 1.76, and divide it by 2. How much would be the average? Negative what?
Negative 0.1755.
Just a second. What?
No, I said it wrong.
Yeah.
0.1755. Negative point. No?
No, negative 1.76. Negative 1.76.
1.75
5.
and 5. Thank you. Can you understand how can we get the z-score?
Yeah.
Yeah, we can go back home, right? Yeah, reverse way. Before, we got a z-score and we took a probability. Now, probability was given to take the z-score from inside to outside. Before, from outside, get inside to get the probability, right? So we are going to reverse way. Okay, now, we cross the bridge this way by this.
So now we can do
We have
that.
to go here, right?
Yeah.
We need another bridge. It is the mean add the z-score, what we got, times the standard deviation. So the mileage will be, how much was the mean? 32,000 miles. Add, how much was a z-score? Negative 1.755. And who was the standard deviation? 2,500. How much?
27,600.
Say again?
27,612.5.
Miles. Can you go home?
Can you go home? I don't know. Sometimes I can't.
Any question?
I get it though.
Please remember the math. You can go home. You can go home. Okay? Please look at the first one. When we go this way, right, to get the z. Some reason, I want to just multiply the sigma. Just multiply the standard deviation. Please don't ask me why. I just want to. Can I cancel them out?
Yeah.
Why not? Now, I just want to add the mean. Don't ask me either, right? Can I cancel them out?
Yeah.
Yeah, why not?
So there you go.
Who's this?
Your answer.
It is the ticket to go home. Nothing. We can take this from here. That one from here. Nothing. When we needed z, this way. When we need the x there, this way.
It's a good little road map.
Any question? Yeah, please take a picture. Yeah, it's a beautiful map. You can go home. It's party.
Oh dear.
Yeah.